topic for this section is integrity codes. Integrity codes are used to detect the changes to the data either accidentally or by deliberate errors, such as during the transmission between the sender and the receiver. So, a middleman can change the data in between. So to detect that changes, the integrity codes are used. So first technique is checksum versus cryptographic hash. So checksum are a common type of basic integrity code and are transmitted with the data. It is transmitted with the data, and the receiver applies a simple formula to the data and compares the result with the integrity code. So here the parity bits and the cyclic redundancy checks are the examples of the checksum. As we know, parity bit is added in the data, so it may be a even parity or odd parity. If there is a even parity, and if suppose the number of ones in the data is odd, then the parity bit is inserted as 1, otherwise it is inserted as 0 for even. And similarly for the add, if the number of ones in this data is even, so odd parity bit is added here, so complete parity of this data is odd. So that is the even and odd parity, and at the receiver side it is checked for the even and odd parity respectively. Next is the cyclic redundancy check. So it is a more sophisticated checksum that uses the polynomial math to compute the parity bits. So most widely used CRC is the CRC32, which is of 32 bit. Next is hash function. So hash function is a function that takes an input of arbitrary size and it produces the output of the fixed size output. Okay, and the cryptographically secure hash is a one-way hash function in which a small change in the input result a very large change in the hash. Then message authentication code. A message authentication code is a one-way hash function plus a secret key. MAX can be performed in two ways. In the first approach, the function computes the MAC by encrypting the hash and of the message and the key. And in the second approach, the function computes the MAC by taking the hash and the key concatenated together. Okay, so MAC protect the message authenticity without secrecy. MAC serve as a type of tamper-proof seal, allowing the easy detection of changes to the original message. By using MAC, we can detect the changes because the MAC uses a cryptographically secure hash, as we have discussed in the last section, and any change to the message result a very different hash. MACs are relatively low cost. It is very relatively low cost to protect the integrity of the message, and there are various ways to create a MAC, like putting the key in the beginning or putting the key at the end. So there are different techniques to compute the MAC. Okay, so thank you.